Hey, good afternoon or good evening again. This is Coach Scott. So I went back and re-looked and rethought, and so the key word there is it is ionic. So I was right. N2H4O3, N2H4O3. I've got to think about that one, right? Got to think about that one. All right. So do I have any polyatomic ions with NH? I do. All right, I do. If I look real hard, I can find ammonium, which is NH3. All right, and that accounts for the 4 hydrogens, 1 nitrogen. So I got 1 nitrogen left over, right? And nitrate, or NO3, is also a polyatomic anion. So I got a polyatomic ion, cation, and a polyatomic anion. So that took care of that. Whoa, this is going to be hard. We'll try. So a substance has a empirical formula of CH2Br and a molar mass of 188. What's the molecular formula of the compound? Well, first I've got to determine what the empirical formula mass is. The empirical formula mass. So I'm going to move this over here just a little bit and just do it on this paper here. So it's CH2, Br, and the molar mass is 188. So the empirical formula mass, let's calculate. All right, C. There's 1 carbon. Carbon has a mass of 12.011. Hydrogen. There's 2 of those. 2 times 1.008, if I recall. 1.008. 12.011. All right, I'll multiply that. And Br. There's 1 of those. And bromine has a formula mass of 79.904. 79.904. So 2 times, okay, I got to do this. 2 times 0.008. Would be 2.016. Multiply those two. 79.904. 79.904 plus 12.011. I get 93.931. Okay. So I've got to see if there's any type of factor, if you would. So what I want to do is I'm going to divide the molar mass, 188, that was given, grams per mole, and divide it by the empirical formula mass. And if I do 188 molar mass, the molar mass of the actual molecule, the molecular mass. That's what I'd rather use, molecular mass. That to me would be a better name. And then 93.93, that's the empirical formula mass. And that's going to give me a factor of 2. So now, in order to get the actual molecular mass, I've got to multiply everything here by 2. So now I've got C, H, and Br. I started with 1 carbon, so now that's 2. I started with 2 hydrogens. 2 times 2 is 4, and 2 Br. So this answer, or this compound, would be C2H4Br2. All right. So if you look at number 5, let's look at number 5. We'll do that one. The common pain formula, Advil. Some of y'all might be taking that. Some of y'all make me want to take it. Contains the active ingredient ibuprofen that has a molar mass of 206 grams per mole. Ibuprofen contains 75.73% carbon, 8.74% hydrogen, and the rest is oxygen. You got to do that subtraction thing again. What's the empirical formula, molecular formula for ibuprofen? So let's do some math here. Oh, yay. All right, let's move this down a little bit, or move it up, rather. So I've got the ibuprofen molecular mass. Let me get this over. Molecular mass is 206 grams per mole. All right. Ibuprofen has carbon at 75.73%, hydrogen 8.74%, oxygen the rest. So I'm smart. I know if I take 100 or 100% and I subtract 8.74, then I subtract 75.73, that will give me my percentage of oxygen, 15.53%. So, knowing that what we've got, now we can actually work it. Let's do our table. C, H, and O. Alright, so let's put our masses in there. 75.73, hydrogen 8.74, oxygen 15.53, and right now we just made those grams. So now we've got to put the molar masses in, okay, the relative atomic masses. 12.011, hydrogen 1.008, and where did I get these from? Periodic table. 15.999. Now I got to do some division. All that arithmetic again. 73 divided by 12.011 is going to give me what? 6.3. 6.3. Hydrogen 8.74 divided by 1.008. That's going to give me the number of mole 8.67. So 8.67, or really that's 2/3. Keep that in mind, and that's about 1/3. Okay, 15.53 divided by 15.999. It's going to give me 1. 0.97 is 1. So if I multiply 6.3, let's do that. Trying to get a whole number. The only whole number I got is right there. If I take 6.3 times 3, what does that give me? 18.9. Yeah, I can round that. So let's put a 3 here. 6.3, if I multiply that by 9, I'm going to get 19. All right, if I have, what is that, 6.67 times 3, that's going to give me 20. That's good. And then 3 times 1 is 3. Ooh, you know what? I screwed up. And this is going to be a problem. I did that on purpose. Yeah, right. All right. But it just happens to work out. I need to divide these. This is giving me moles now, so I've got to go divide through by the lowest denominator. So I'm not going to round here. If I recall, we got a 0.9. Right? We did. 0.97. So let's divide everything by 0.97 to give me a whole number. That's one. 6.67. Is that what I got, or is it 8.67? Oh, 8.67. Make sure you can read. 8.67. 8.67 divided by 0.97 is going to give me 8.93. I can almost round that. And then 6.3 divided by 0.97, it's going to give me 6.5. 8.93, let's make a decision. Let's go ahead and round that. So that's 9. So I need to make that a whole number. Get rid of that. Get rid of all that. Other than we divide it through by 0.97. If I multiply by 2, that's going to give me 13. That's going to give me 18. That's going to give me 2. So that would give the empirical formula of C13, H18, O2. Now let's see if that's going to give us the right molecular, or the empirical formula mass. Let's see what that is. See if that is, it could be the actual formula, or this could be the actual formula. So if I've got carbon, I've got 13 carbons times 12.011. Where did I get that from? Where did I get that from? I got that from the periodic table. Now I'm going to add that to 18 times 1.008 for hydrogen, plus 2 times 15.999. I got 206.285. That's 206. So that tells me that we did this right, that this is actually the empirical formula for this compound. That's what Advil is. I'm going to do one more real quick one. Our last one, actually. All right. The last problem. The molar mass of the common antibiotic oxytetracycline is found to be 460 grams per mole. 460 grams per mole. All right. And a 2-gram sample, contains 1.478 grams of carbon, 0.10435. We're going to come back and do that one, okay? So as soon as, let's go ahead and publish this, because this is going to take a little while, because we're going to have to find those percentages, and we'll be right back, okay?